up with my screen and voice? Are we all there?
You sound wonderful and you look.
Yeah, I definitely have a face to radio. So you guys got the intro now. Hopefully you can see my slides. So I appreciate some of you chiming in. It's great to see and hear where you're at and what you're doing. I do have a couple polls to kind of give us an indication as to who's all here. And again, I probably have about 8 hours of information to cover for you, but we will see what we can do about covering the priorities in about an hour for you and go through lunch. So, or maybe late breakfast for some of you, no matter where you're at. It could be dinner for those of you in Europe. Let's cruise through some of these, and that is my reminder that I should be recording, and I will start my recording now. Great. That is my QA that I tried to implement into my webinars. So many of you are used to going through this in the beginning, but if you're not used to it or new to webinars, the little red arrow opens or closes the bigger panel that you can control your sound and other options in. And some general information is all there. We really enjoy your feedback. We don't honestly use this stuff for like marketing. You're not going to get a bunch of sales emails or anything like that, but it kind of gives us a feeling as to who's out there, what you're doing, and which way to go next. Even for this webinar, I kind of guide the direction based upon some of your feedback. So please give us your feedback, your questions. Any comments are always appreciated. And you should have sound now, because I've confirmed that I do have sound out there. And Alan and many people always ask, we get a copy of the slide presentations. We will have a PDF copy that we post, and the presentation is being recorded, and that shows up on YouTube in about a week or so. We keep striving to try and get a PDF that includes some of the links, and we are still determined to make that happen. Many of the information, the illustrations, the drawings, and all stuff, the things I have today, comes from the Retrotec.com website. I am actually an independent trainer for Retrotec. It is not my goal to sell you anything. In fact, some of my slides sometimes include Energy Conservatory, and it's our goal to promote the industry. Right? So if you're looking for some of the information that I have here, or illustrations, they're usually in the quick guides, and they kind of go through exactly what we're going to cover today. So it's a great resource, and they have some, under support, we have quick guides. We have webinars. All these things are a great library for you to pick from. The quick guides are obviously like a field guide, how-to, and there's actually some that are actually designed for code officials. And the manuals are an in-depth study of the actual topic, from air sealing to blower door or duct testing, and many of them are several hundred pages that cover the topic in general in a variety of ways. So if you're looking for some phenomenal information, dig into one of the manuals. You can always reach out to Cullen Ginge directly if you have a question about them. He responds directly to your feedback. So whatever you're doing, there's a guide to help you go through it, and they actually work as a great QA process because they have little check boxes on them, and they have ways to check your gauge that should be done weekly, or at least before a test if you're not testing weekly, and even how to check your blower door and other fan systems. For those of you that have the DM32, so if you have the gauge, the touchscreen gauge, you should make sure your firmware is currently on version 42. You can see that on the front of the screen at the bottom when you first turn it on, or you can go to settings and toggle through a few pages, and on the back it'll have firmware information. If it's not 42, then you can hook it up to your PC with the configurator, or download the configurator if you've not done so, and we highly recommend you update your gauge or keep it up to date, because there's lots of great improvements. That's why that gauge is such an amazing device, because it actually can update itself. I am actually an IECC residential and commercial code plans examiner, inspector. I took my first test back in 2006, where there were trade-offs and other challenges. So I am very in tune with the code and do keep up with my certifications and all that with ICC. I'm also a residential building official, again, non-practicing, but I play one on TV. Or on webinars, and that's one of my personal achievements is doing that. I do want to go back and do some others. If you have not thanked your building code official or code official, I highly recommend you do so. Some are, challenged individuals. Some are, we all have our idiosyncrasies, but their job, I personally feel, is an incredible challenge to figure out a way to help guide builders on what they have to do, and also maintain a great relationship for them in the community. So I highly encourage you to appreciate your building code official. Christmas is coming up soon. They would gladly appreciate any kind of gift certificate or a lunch gift certificate. So anyway, I'd always recommend you compliment those guys on what they do. And Jesse, I will touch your thing about not reaching 25. So leave some of those questions up there, Jay, so I can check on them. So for 2009, the slide that I had here was that your leakage outside is an option. The total leakage gets reduced significantly in 2012, and you can either do it at post-construction or as a rough-in, but it's the same number. In 2009, they gave you an advantage to do a rough-in, and there's even another one where you could do a rough-in without the air handler, which even made it even tighter, so you're just testing the actual duct systems. So these are the criteria. So some people are actually still on 9, are going to go to 9 or adopt these themselves. Georgia adopted this and had a few more amendments, and even adopted blower door testing at the same time. So the 12 really starts to make ducts incredibly tight, and if you're not on your game, it'll be a little challenging as to when this comes into play. So we're now down to 4 CFM per 100 square feet. And just as a reference, years ago, the Energy Star, which was a high third-party standard, was at 6 CFM as a good achievement, or a place where you wanted to get down to, and then they got it down to 3. And so the code is really trying to keep up with the third-party building requirements, like Energy Star and LEED and others. So we really are kind of pushing the limit and the envelope, literally, to create some high standards. So if you have questions about these, I gladly can go through them, but those are actually the requirements. There's some stuff to set up, which my slide didn't work well. So Retrotec and Minneapolis do things a little slightly differently. It's the same test. It's the same fan. We highly recommend you depressurize. There's only a few jurisdictions that state you must pressurize. Maybe that's because the flow is the same as the HVAC system, but the reality is we feel you get a much better test when you depressurize, because when you are depressurizing the system for the ducts, you actually are pulling all of the grill mask or the duct mask really tight against the registers, so it has a really good seal. Sometimes if you pressurize, you may have separations that are very small, or you don't realize that you have air flowing out of the register underneath some of the duct mask. So depressurization is a much better process. And for the Retrotec fans, you literally can just turn the fan around. There's nothing else to change. You just separate it from the flex duct, turn the fan around, and reconnect it. And the rings or the ranges will actually be inside the flex duct when you depressurize. And all of the tubing, everything stays the same. It's a very simple process. So if you want to even do both or experiment, it's simple to do. And here's leakage to outside. So I'm going to jump back to it because here I want to just do, here's the depressure, the process for depressurizing. So if I can pressurize the same concept, sorry the slides got out of order, I forgot to rearrange them. So now instead of depressurizing, we're just going to pressurize. So you can notice I turned the fan around and you can see the red ranges or rings there on the bottom, and now I'm pushing air in versus pulling air out. Right? So again, I could have some small separations with the grill mask, but either test, any testing you do is a great test. So you can decide which one works well for you. The depressurization for this process has some other benefits, which I'll come back to. Okay, so I'm going to stay with the pressurization because this is the common one that everybody does actually do. And this is now leakage to outside. So leakage to outside is a concept where I want to neutralize any leaks that I have coming into the interior here. So all of my leaks now are considered total leakage at this test because it could leak from in the ducts in the attic or crawl space, or there could be leakage from a return or something else that leaks to the inside. When I set up a blower door and I'm actually going to pressurize the interior of the house, what I get is actually this area down below gets neutralized because I now actually have an equal pressure that goes across the envelope. So I separate the ceiling or the floor, wherever the ducts are, from the house to the outside. And now the only place it can leak is outside. So some method of testing is I can actually bring up the fan to 25 pascals, and then take the ducts and take them to 0, which creates a neutral pressure. But notice that here on the Retrotec system, we've added, this is the duct tester where my pointer is, we added an extra reference, which is the red. So I'm now going to reference outside, same place that the blower doors testing, whether you combine the tubing or you run your own tubing outside, that now I'm actually referencing outside for the duct test. So it has its own separate reference. This allows you to actually go to 25 pascals and not try to find 0. And it also allows you to use the add feature that's on the gauge, which will help you confirm of what your results are at 25. I'm going to go back to the slide I had a second ago. This is that order. So this is, here's why this is one of the tests that I think is, so usually you set up the blower door and you depressurize as a standard operating test. And if you depressurize your ducts, basically you can do one and then do the other, and everything stays the same. There's nothing to actually change. And then I can seal off the ducts and then do a total test. So this was my leakage to outside, and then this is my I'm missing a slide. Perfect. There it is. Sorry, I'm missing a slide. That's frustrating. So anyway, I'm going to move past the. It's similar to the concept where I had pressurization. You can do the same with depressurization. Basically, somehow I lost the illustration that showed up with that. So instead of pressurizing both, I can actually depressurize both, and it works the same. They actually will just pull on each other until they equalize the same number. So it'll be negative 25 and negative 25, and I can get a number that is leakage to outside. Another way that some people test is they'll do the test to 0 method, which looks something similar as though I have my duct tester that's normally set up and gives me a total leakage. And then I can actually move on to adding a blower door. And now I'm actually going to pressurize the area. So this is a pressurization test. And wherever I have leakage, I will actually end up with air moving into the ducts. And this is the test to 0 method, where I now actually add my duct test, and it will pressurize until it gets to 0 and negate the actual area that's in the house itself. So there's 2 ways to test. The code does not clarify which way you go or how you actually set that up. So I didn't have a lot on duct testing because many people are actually doing that already. A lot of people are headed towards the blower door. So I just want to see if there's any other questions about, so Al asked, what's the advantage of putting the hose outside to a manometer? The advantage is that I have a much easier way of maintaining the pressure at 25 versus trying to get it to 0, or if it goes past 0, it's a lot easier to let the gauge do the work. It's hard to tell the gauge to go to 0 or do set pressure 0. A lot of times it overshoots 0 and it doesn't want to come back. So you can do it manually on the fans, but it's a lot easier to actually just set up my system where I can tell the duct tester to go to 25 pressure or depressure, and do the fan. As long as both fans are doing the same thing, pressurizing or depressurizing, it's a really stable way to actually test and confirm what you have. And you get to add the add feature to confirm that.
Hey Joe, we got another question here. Are the grills still taped when doing total leakage?
So total leakage is the grills are sealed off, right? Because what I'm trying to do is just do the duct tests themselves. So total leakage, I've sealed off the ducts, and I just want to find out where they leak. Total leakage means they could leak in the house or they leak to the outside, wherever they may be. And but if I'm doing leakage to outside, then I actually have them open because I want to see the pressure difference that actually is created across the opening of the registers themselves. Now, you do not have to test. No testing is required if the air handler and all of the ducts are in conditioned space, or a lot of that becomes semi-conditioned space, and there's a lot of gray areas with how your code official may determine that. But clearly, if it's down in the living area, that's considered to be conditioned space. Obviously, if you take the attic and you bring the attic, the roof line, into conditioned space, then so are my ducts also, and that can also alleviate testing depending on how your code official may determine that or put that in. I think William was asking, does duct blasting, we also blast ducts, dictate whether leakage in the supply or return duct system? And the type of testing that the code requires doesn't separate that. It actually is just total leakage. If you want to try and isolate the return versus the supply, you can go to the air handler and put some kind of a cardboard or something in there that separates one to the other, and you can test them individually. Can dirty X claws or damage the duct plaster? So that's a common question. It usually doesn't affect your duct blaster or duct tester. What it can affect if you're doing kind of more of an existing home is that if they're really dirty and you're doing pressurization and something separates, I will blow a bunch of stuff into the house. The opposite can happen, that I could actually be pulling stuff into the house. So if the ducts are really dirty, you definitely could sometimes even see indications of that just by looking at the registers, but I would be cautious about that. Energy Star does still require leakage to outside, and no matter what they are. Energy Star wants to know, you know what, are your ducts well designed, and are they actually leaking no matter where they are? And I think that's a good habit to follow. This is any other questions on duct testing real quick? Check it over real quick. Yes, my point. It depends on which method or how you want to do your blower door duct tests is when you'll decide to cover them to do a total leakage. And confirming, when I do leakage to outside, my registers are open. They're not actually sealed. I actually can get a separation right there. Okay, so moving on to blower doors. If you still have another question about duct testing, we gladly will grab that from you. So blower doors are something that many municipalities are moving into, and for some reason they find this to be the more challenging or test that has potential issues. And the reality is they're right for one reason, and that is that if you're going to test the house when it's completed, you're ready to move the occupants in, and you have issues, they are not easy to find or get to. So if you have issues with your ducts, many times they're actually fairly accessible, and I can get to them even at any time in the stage, whether it's attic or crawl space, or unless they're totally sealed off inside the area, and a lot of times they weren't tested anyway. So the air barrier is a challenge for builders, and most builders that start off fail. It's like doing anything new. There's a learning curve that goes along with it. So I encourage you to talk to your builder, your code official, about how challenging this could be in the beginning. This is the definition of what an air barrier is, or also referred to as air control layer, and that's 2009 and 2012. They added the word continuous, so that you can't just have a variety of air barriers, that it must be a continuous connection of controlling the air barrier around the structure. And a lot of times this shows up in places that are around fireplaces or other soffit type conditions where the air barrier sometimes kind of got forgotten or really wasn't a full connection. I will not take on the debate on whether or not house wrap is an air barrier. that's another day. So there's a variety of the ABAA, Air Barrier Association of America, has some phenomenal videos and criteria about what is considered an air barrier. But basically, if air doesn't move through it, in general, it's kind of considered an air barrier. The code has this phenomenal checklist, and if you're new to blower door, if you're working with a builder, I highly encourage you to make sure that they check these 17 areas. Most people that actually do a good visual assessment pass. When they just hoping that they do what they normally do without actually being very detailed, that that's when things happen and it's already too late to get to them. So this checklist, and many times it's actually required even if you test, that you must actually comply with this checklist. So Georgia created some phenomenal illustrations that actually coordinate these numbers specifically to the code and where it is. So if you're dealing with, you know, areas around the tub, those actually coincide to the numbers that are here, right? So most people ask, oh, where can I get these? These are free. You can use these for yourself, give them to building officials, give them to contractors, whatever you want to do with them, all right? They are a phenomenal resource. And they really kind of do highlight some of the realities that you see on the left and how those can get overcome. The one that's mostly a common challenge for people is the attic and the knee walls that you can see now what a typical knee wall would look like, but now it has to be encapsulated on all 6 sides with an air barrier that also complies with your ignition or fire rating concepts. So these are what a really well done attic would look like. These knee walls are taken care of ahead of time so that you could insulate from the interior and everything happened all at once. I'll give you a few seconds if you want to write. Jay's going to actually post these 2 URLs out to everybody. I sent them to him earlier so he can send them out. So you're going to get these 2 URLs. The top one is actually the illustrations that Southface has created. And if you want to write it down, this is case sensitive, but this is the short version. And they also went one more step, is they actually created a field guide on how to do air sealing. So they actually have all these same areas and what are the proper ways to be sealing ducts, do the attic, and take care of some of these. And this is the link for their energy code resources. So you'll get links for those, and if you were able to write them down, that's great. So David, hopefully you wrote them down, and if not, Jay should be sending out an email. Look in your chat window for the links to those. Someone asked, why don't you seal the registers when you do leakage to outside? Is because you're actually able to create a neutral pressure between those 2 scenarios. And it's just a standard of how they've actually done that. Here is your question I usually have about where is the air barrier in your house. And if I just had a 1-room bungalow with no receptacles, no windows, nothing in the house, it's very easy to see that I can keep track of my air barrier. Typically, it's the drywall is the most common air barrier source, and it should always be aligned and connected, actually touching your insulation or the thermal load that you're also trying to control. If they're touching, they work really well together. So, but what happens is that we actually start cutting holes in it, and we add some framing. I've got other things that start showing up. Now my air barrier has been separated. Now I actually have connections between the attic or crawl space from some holes for some electrical wires. Now I've got pathways for air to be moving directly up and down my walls and come out either receptacles or plumbing openings. And if you add your air handler or can lights or a junction box, once I penetrate or cut any part of the air barrier, then that element actually becomes the air barrier. So if you start following the air barrier around, you can see that the junction box becomes the next connection between inside and outside, or the air handler actually will also now become your air barrier. If there's leaks in your duct system and you run your blower door, which is where we're headed, it will actually allow air to move through your air handler or your duct system and come out the registers when you have leaks, because it actually wants to know where's the separation between inside and outside, and it will help you find all of these locations. So we take an average home and we kind of cut it apart. We put a bunch of darn windows and doors, and we add openings for receptacles and vents in the roof, and so we end up making this monstrosity of a whole bunch of openings. Most of your windows are phenomenally well sealed. It's the large opening around it, and same with the doors. So we have these a much larger opening than we do actually for the door or the window itself. So I made this illustration that tries to show that what our homes really kind of feel like to me. And it isn't always just the envelope. It actually becomes also the conditions that are connected between floors that also are a major issue, whether it connects to the attic or maybe it connects 2 floors or to the crawl space. That these are just some of the penetrations that happen from plumbing, not including electrical or can lights or some of the other smaller openings that all add up to large significant leakage between attics or other floors or exterior and interior, that we're back to this major Swiss cheese element of a house that we end up creating. So we have a whole lot of openings that are in the house, and our goal now is to actually test them and figure out what these issues are. This is a quick illustration that hammers home why these little openings make a big difference. This is from buildingscience.com. Joseph Stiebers has a study that they did. I'll explain the study briefly here, and that is that I have 2 sheets of drywall on each side. They're both a 4x8 sheet of drywall. They both have the identical temperature and relative humidity. So it's only 50% relative humidity, very, very tolerable. 75 degrees, very nominal, right? And so one is actually diffusion, where you actually have moisture that moves through materials. All materials usually have a diffusion element, or one small square inch hole based upon these small conditions, right? So after 1 week, they measured how much moisture can move through a tiny little 1 inch hole. And over here we have 1.2 pints of water that diffuse through the materials. The other side has 14 pints of water. So it was a significant amount of moisture that comes through a small hole. The average home has an opening that's equivalent to around 2 square feet. That's actually a code compliant house. So it's easy to imagine how much moisture load gets pulled into our houses year round. So it's a phenomenal illustration. So I'm going to go through some basic stuff about how the blower door works. Basically, we're going to set this up at any door. Usually it's the front door, but if the front door is too big or is a double door, you can also use it at any other door that has a free air pathway on the other side. So you can use the garage or the back door as long as there's no restrictions for air to flow out of the doorway itself. And we're going to create a pressure difference, and the fan itself will also measure the pressure inside of it and how it will convert that pressure inside the fan to CFM. And then I can actually compare that CFM into a calculation, and now I can compare it to other houses, and now it's actually a standard on why this is a great testing method. It allows me again to compare to other houses or find leaky paths, or when the blower door is running, if you have not experienced this, it is shocking the amount of air that flies out of your receptacles and switches, or underneath your trim and around your floor, around doorways that are interior doors where air is coming straight down and finds its way out of that path. We measure the difference in what's called a Pascal. 1 Pascal is such a small fraction of pressure measurement, it's almost impossible to really describe. So we do duct testing at 25, right here. This is our duct test, and we do the blower door at 50 pascals. And 1 inch of water column, which is basically using a straw to try and suck up liquid, from 1 inch is 248, we call it 250 pascals. So we're only using 0.2 of that, a fraction of that, and this is 0.1. So next time you have your drink and you have a straw, I would say up higher, it's easy. Just make a mark that's 1 inch apart and see if you can, how little effort it takes to move 1 inch water column, or if you can just move it a tiny bit. The bubble itself is more than actually 50 pascals. So it's an interesting comparison as to what Pascal means. So I have my blower door. It's in the front door, whatever door I have. I'm going to set it up to depressurize. The code actually doesn't clarify that, but I can tell you that depressurization for a code house is the way to go. You're going to depressurize the house, and I'm going to create a 50 Pascal difference. That's when I know I have enough pressure difference between inside and outside that I can then make a measurement that I'll convert to CFM. So what it actually does is pulling air from inside to out, and then it also will show me that where else I might have leaks that are inside. So anywhere where I'm taking 50 out, in theory I have 50 Pascals coming in. These are actually pressure measurements, but it's easy to kind of understand the concept of pressure out means I must have some kind of pressure or air coming in. So here's the basic understanding. So I'm going to set up my house with a media not found. Okay, great, thanks. All right, we'll come back to the illustration. So most people want to know, well, how big is the hole? How big is the area in my house that you can describe to clients, right? This illustration has been donated from South Face, so I appreciate it. I don't know who that is, but your blower door provides you with information from CFM, and I can basically kind of divide, let's say I have 4,257 CFM. You divide that by 1,000, and it tells me approximately how many square feet of an opening that somebody may have. So at 4.3 square feet, that's a little more than, 2 times 2 is 4, so you have a pretty good opening of about 2 feet by 2 feet based upon these results on this test. Here's the basic overview of doing a test, and that is that you really should evaluate the crawl space, the attic, and the duct system, even if you're doing a new home, to make sure there are no issues. If the duct system is totally separated, it will affect your blower door. I highly recommend you make sure all the doors and windows are locked and the garage is fully sealed off before you perform any kind of a test. It's common that people show up, they pull out their fan, they start testing, and realize that there were some other conditions that they really should have just done a visual look at. In general, you're looking for issues that may have a problem. Again, if it's new home, these things don't commonly occur, but some people do use the fireplace in colder areas to heat the place before it actually is occupied. So you want to make sure you do check some of that, and that there's nothing on, nobody's drying their shirt that got wet in the morning in the dryer. All other fans are off. If you have hot water tanks, you want to make sure they're turned to pilot and leave your keys there so you don't have to come back later to find out why there's no hot water. Thermostats, you want to set them to either off or adjust the temperature so they will clearly not come on. And again, even though it's code compliance, you still want to be cautious about any kind of combustion appliances that are in the house. Again, your goal is to do no harm or make everybody pass out while you're doing your blower door test because you are bringing in fumes from someplace else. This is a quick basic overview about how simple a blower door is. This is kind of about a 2-minute picture overview of where you take the frame out. Retrotec provides these phenomenal instructions that are simple checklists, like I mentioned earlier. Frame snaps together, and you're going to take it to the door and kind of do a quick overview. You want to make sure that you have some extra room around it, because when I bring it back, I'll have the cloth there, and I want to make sure I have some extra room. I can add my crossbars. The new frame that Retrotec has 2 crossbars, which is a great feature, very stable. This is the cloth that actually will separate the inside from outside. You lay your cloth down, and they have done a few nice little features. They've added some pockets. They've readjusted their Velcro. And if you have any improvements about how this stuff works, most of these have come from users like yourself. So you make sure it's secured, you put your foot on the bottom, push things around. There's some cams that are engaged. Both manufacturers are very similar to how this whole structure comes. You want to make sure it's fully secured in the doorway, because when you turn this on and create a pressure difference, if it's not really well secured, it will all fall flat onto the floor. What he just installed was a reference tube to go to the outside. You want to make sure it's fully away from the fan itself so that the pressures from the fan as it blows out don't interfere with the actual test itself. You connect the gauge, whichever gauge you use. It's a very simple procedure. Add some power. Notice that the fan is covered right now, because what you're going to do is you're actually going to set up and create a baseline, knowing is there any kind of pressures that are on the house that are different from inside to outside, and you want to kind of zero those out, whether it's actually a significant wind or an amazing stack effect, which would be a pretty phenomenal number, or just other conditions. So once my baseline is set, we highly recommend people to kind of go to 20 or 25, make sure nothing is falling apart, and then go to 50 to get your results. So these are the requirements for doing a blower door test with the 2012. Most communities are altering these requirements, so I'd like to also get some feedback about people who felt that 3 air changes per hour was impossible and have altered that number. If you're dealing with 3 air changes per hour on a small home with a slab, it is a difficult test to achieve 3 air changes per hour. I have an illustration about how air change per hour works, but air changes per hour basically means is how many times does all the air in the house get pulled out of the house while you have a blower door running. So when I have my blower door up, it's actually pulling air out of the house, and I can actually calculate how many times all the air left the house, and that's 1 air change. And when the blower door is running, I can now determine, do I have 3 air changes per hour or 5 air changes per hour? And so for the lower states, Zone 1 is only a tip of Florida. Zone 2 is chunks of maybe Texas and parts of the South, but most people are in climate zone 3 or more, so 3 air changes is a challenge to achieve that. So if anybody's having success with that or have altered that, that would be great feedback. So Alan commented about doing a pressurization and depressurization, and that is actually kind of a commercial type of a standard. It can be done. What you'll find out is if all of the dampers that the house has really should get pulled tight when you do your depressurization test. That's why people depressurize. And if you pressurize, you may be negating any kind of wind issues that may be affecting the house that day, but you're going to end up opening up a whole lot of other openings that aren't really supposed to be sealed technically. So in general, you're better off just doing a depressurization test, and if it's a really windy day, I would just come back or come back later in the evening or early in the morning when the wind may not be such a factor. These are the requirements to do a blower door test. Yes, Jay?
Thanks. I was going to add to that. I also mentioned in there, Alan, that just keep in mind that the most important thing is that if you're going to do that test multiple times, which you're probably going to, if you don't pass the first time, then obviously you're going to want to fix it. Or if you're working retrofit, you just want to make sure that everybody is doing the same tests the same way. So I think that's probably the biggest thing. You don't want one guy pressurizing and then one guy depressurizing. And I hope that helps a little bit. Thanks, Joe.
Sure. And Jesse, I still got your question about the duct testing, so I'll come to that as we kind of wrap up here. So these are incredibly simple requirements for doing a test. And if you compare this to like a ResNet standard, which is 28 pages, most of the requirements that are in the 2012 are only part of 1 page. So there's multiple things that they did not include in terms of testing requirements, or I think they just assumed that whoever did the test would know what they were doing. So I think they're going to revamp that as time goes, and if not, I think they'll find out that they need to add a few more criteria. Air changes per hour is based on volume. So like I mentioned earlier, if you have a small house on a slab, it's tough to get to 3 air changes. But if you actually have a larger volume in the house, then it's a lot easier to complete that pathway of actually getting to the air changes you need. So homes that have a basement usually don't have a lot of air leakage around the basement because it's either enclosed with earth or the blocks are fairly well sealed or it's even finished. So that really allows this super bonus volume that allows you to easily pass. I went out to Nebraska a while ago and we tested a couple houses, and it was clear that if we took out the basement as part of the volume, the upper half would not get to 3 air changes per hour. They were lucky to get to 8 or 9, but this extra volume clearly made a difference for their ability to pass that test. And again, we're only dealing with conditioned area. Now, the roof line may have been part of a semi-conditioned or conditioned area, but in general, we're only after conditioned areas. So this is 6 air changes per hour. So my other illustration didn't work, but this one does. So what it's saying is when my blower door is happening, I'm actually able to calculate how many air changes are occurring. Again, notice that there's a little number 50 that's near a lot of the places where we have air changes per hour. At the ACH, 50 means that there's a blower door running at 50 Pascal difference. So that helps us to, again, measure this and do a calculation to confirm, like I use 6 as a generic number, but your goal will be to get to 3 or 5. Georgia now is at 7. So these are some of the things that trying to illustrate that when I have my blower door, it can actually calculate the CFM, cubic feet per minute, in the fan, and then I can actually apply the calculation to do that. So here's a simple illustration of the calculation. So I have to determine the entire volume of the conditioned area. This is the actual way to calculate air changes per hour. So the final fan flow is the CFM that comes from the gauge. You multiply that from 60, because I went from minutes to an hour, and divide it by the volume. So if I had 1900 CFM times 60 and add a volume, then I end up with 3.45 air changes per hour at 50. And you can do it on your calculator, or the DM32 or the DM2 will calculate this in the gauge live as you actually test. So you can actually confirm exactly what my air changes per hour were while I did that test. Oh, that's moving the wrong way. Here's one of the questions I get frequently is, when is a house too tight? And when does a house require mechanical ventilation? And clearly it's less than 5 air changes per hour at 50. And if we go back to our 2012 code, that means everybody. So it's kind of a catch-22 that clearly you're less than 3, you're going to need it. And if you're going to comply, you are maybe at 5. So there's a gray area with how you interpret your numbers, whether you are 5 or less than 5. So so if you're going to test and you've confirmed that the house was less than 5, technically you should be adding mechanical ventilation. If somehow you achieved 5, you might be able to get away with confirming I do not actually need it. If you're above 5, you don't pass your certification anyway. So there's a variety of places where this is all referred to in the IECC and IRC, in the mechanical code. All of these highlight what are the requirements. I don't have the slide that actually shows it, but it's basically exhaust fans in a bathroom need to be not just rated, but actually performing at 50 CFM, the cubic feet per minute, and that your exhaust fan in the kitchen needs to be at 100, and again, not rated, but actually performing at that level. There's a variety of ventilation options between just doing negative, where I just have exhaust fans, or I can do basically positive, where I bring air in with the HVAC system. Another option is you can actually do balance, which is ERV or HRV. If you're trying to determine your compliance or what my options are, or if it's working, we send people to RED, which is the Residential Energy Dynamics website.com. And Rick Karg and his associates have a phenomenal website to guide you through whichever test you're doing and whatever you're trying to achieve, and they have awesome help features on each one of the things to confirm where you're getting your information. So if you want to understand more about ventilation and the requirements, this is the place to go to. Here are some methods to test your exhaust fans as we'll wrap up here. So You can use the Energy Conservatory exhaust fan flow meter. It's kind of like a large plastic box or a cake cover with a slider that allows you to control how much air moves through it. And that device works great on the any of the Retrotec manometers. You see on the picture on the left, I have a DM32 there. Notice though that I color-coded it correctly, that I'm able to read on channel A the pressure, and B actually gives me the results. And you want to use the reference, not the input, on Retrotec manometers. Energy Conservatory uses the input to actually calculate stuff. Retrotec uses the reference to calculate things on channel B. Another option you can use is you can use your duct tester as a powered flow hood, and Retrotec also sells a separate powered flow hood that is an amazing lightweight device that will measure positive and negative pressures. Exhaust fans are really easy to actually measure because the air just moves through. It's a passive collection and reading. It's when you're actually doing positive flows that it's a little more challenging. Here's a basic understanding about the differences between I have an exhaust fan that pulls air out, then I can have a device that clearly will just read the paths that go through, versus having a supply or a ductwork where now I'm actually bombarding the device with a lot of pressures, and it's a little more challenging to actually read those. So a powered flow hood, what it does, whether you use your duct tester or a special powered flow hood device itself, is it actually has a fan that will equal the pressure that moves through. So when the fan spins at the same speed as the other fan, basically the same amount of pressure or air moves through, then I'm actually able to measure that as a total. So the exhaust fan flow meter does well. Everybody asks why doesn't Retrotec have one, and I'm sure it's something that may come out in 2015, but it works great for determining whether or not your exhaust fan is working correctly. You can also use your duct tester, as I mentioned earlier, that basically what you're going to do is you're going to use the blue tube, which is the input, just below your exhaust fan, right? And usually you can have some kind of box or something that may help with the pressures here. And once the duct tester has the same amount of flow, moving the same amount of air, then I can actually convert that into what are my actual results. So it went from a negative number, and then I was able to bring it to 0 by adjusting the knob on the fan, and now I can actually tell you that that exhaust fan is reading 52 CFM. I have more about how to do that, so my goal is just to let you know that there's a variety of ways that you can do that. Kitchen exhaust fans can be measured by making a box with one open area, so I could use different devices to do kitchen exhaust fans like microwaves. Sometimes have 2 openings or 2 fans or a variety of challenges, but you can make a simple box out of rigid foam or something similar that allow you to test that with anything you're doing. I have a couple quick slides that are on ways to document your results. Retrotec has a data logger, and it creates an Excel spreadsheet that you can send to your code officials. It's a great resource. It's downloaded for free and works with either of the gauges, the DM2 or DM32. And you can secure your data on any kind of a Dropbox so you know it wasn't changed. And coming next year is an app that will be a phenomenal resource for the codes, and that is you'll be able to get direct data from your gauge. It'll geotag and time date stamp, stores the data on the cloud, and you can send that to your building official who can actually see exactly where the test was performed and when, and that it complied with the required results.